Welcome back. Let's get going with Chapter 1B. Right, so we've described the concept in Chapter 1A. Now let's get into the nitty-gritties of the infrastructure. So we've talked about the type of objects and associated IoT application considerations for the different types of objects in terms of data collection and transmission. So we will start by describing the infrastructure setup from that point, as well as the associated data collection process. So you could either have an IoT chip embedded within a device such as a fridge or a garage motor, or you could have a combination of a sensor and an IoT external device mounted on an object, for example, a gas heater. So now you've got to collect the data so you could get the insights that you need. There are two ways in which this happens. On an object such as a gas heater, where you might not have the capability to store data, you would need to transmit small bits of data, say the outside temperature or duration of usage for that evening in real time through the network, which then forms a data set after a period of time. On the other hand, if you're dealing with, say, a DVD player with onboard storage, then you can collect the data, store it on the onboard memory, then transmit it, say, every 4 hours if you want. That would largely, however, depend on the type of network that you are using. Specialized IoT networks typically only handle transmission of small, bite-sized data sets at a time, which, depending on the volume of data you're collecting, may necessitate the real-time approach. This data is transmitted via the IoT network base stations that operate at IoT radio frequency to facilitate the collection of data from objects to storage. We'll talk about storage just now. Obviously, coverage is key, so when using a specialized IoT network, the more base stations spread over a large area, say an entire country, the better. Some tend to only cover major cities, which, if the intention is to monitor livestock or television transmitters in remote areas, then things get a bit tricky, unless the entity that owns these transmitters co-invests to install base stations onto the transmitter sites. We'll talk about that more in Chapter 2. Right, so now at this point, each base station has collected the data from objects in proximity to it and needs to transmit it to where it will get stored and analyzed. That's where the broadband network comes in. Why not just use the broadband network to collect data directly from devices to storage then, you ask? Well, connected objects can do that and do that. Smartphones, smart TVs, the app on your phone that collects information from your car via Bluetooth and then transmits it via 3G, 4G, LTE for analysis for maintenance purposes. If you remember from Chapter 1B, that's a broadband application of IoT. With specialized IoT networks, however, it's more about using a low-cost, low-power, and less complex application. Trackers using beams to monitor the location of your car use specialized IoT networks. The beams themselves act as base stations in that context. The base stations are connected, and that's how they transmit data they've collected. To where, you ask? Well, a lot of IoT specialized networks use a global cloud to collect and store information from all devices. This cloud has multiple storage locations for a given set of objects belonging to the network operator's clients. The client will then download that data from the network operator's cloud onto their own, possibly on-site storage. Of course, if the object owner has their own IoT network, That is, they've placed a bunch of beams around their farm with a transmitter attached to each livestock's ear. Then the collection to storage process is much easier since the IoT application is on a smaller scale. Then, once the object owner has their data, they can carry on with their analytics, AI or robotics work that requires that data. We've spoken about data ecosystems and KPI-driven analytics in the analytics translation course. Might be a good idea to revisit that course. The data coming from the IoT network operator's cloud just plugs in as a data source into the data ecosystem. Right, so the data is collected from the base stations into the cloud, then onto the object owner's storage. Then what? Well, the object owner would have structured KPIs they want to measure. That would be the whole point that they embarked on such an investment. Depending on how they structured their KPIs and functions, that will then determine how they structure their data storage. Then you do some modeling to get the required insights. Which you then visualize. And we've come to the end of chapter 1b. We move on to chapter 2, where we will tackle the operational model. See you there.